Welcome to this review of the first midterm of CS159. This is the exam from fall 2019. A few things before we begin. I recommend doing all these problems yourself and getting an answer before looking at the solution. And I will have the PDF of this exam in the description of the video to work out all the problems yourself. Alright, well, let's get started. Question 1. Which of the following is the first line of output generated by the program above? And it's asking us what this first printf statement is going to output. The single function, we have three variables. They're all doubles. We have area, volume, and length. Length is set to 2. And then we have some operator precedence expressions that we have to evaluate. So starting with volume, we have 1 divided by 4. Now, since that's an integer divided by an integer, that's going to be equal to 0 times pentagon, which is defined as 6.88, times power of length, which is 2 to the third. 2 to the third is 8. But we have 0 times 6.88 times 8, which is going to equal to 0, which gives us answer choice C. Question 2. Which of the following is the second line of output generated by the program above? Now we have another expression. We have 5 times power of length to the power of 2. This is going to be 4. 5 times 4 is 9. 5 times 4 is 20. So this whole expression here is going to be equal to 20. And then we have plus 1 divided by 2. We're going to skip the plus for now because we have to go through these divisions and multiplications first. But 1 divided by 2, that's integer division again, which is 0, times the power function of length to the power of 2, which is 4. So 0 times 4 times pentagon, which is 6.88, as defined in the third line of the program. Now, as you can see here, we have to add this plus here. This is going to evaluate to 0. So we're really going to just have 20 plus 0, which is 20. So this is equal to 20. And it will be printed in the printf statement. And so the answer to the second question is B, 20. Question 3. Which of the following statements regarding the programming and documentation standards of the course is true? A. Comment all variables to the right of each declaration made inside of the local declaration section of a function. That is true. You must comment all variables to the right of where you define them in this course, CS159. Now we're just going to go through the rest of them and explain why they're false. B. All code found inside of the local declaration section of a function should be indented by a tab. That is false. In CS159, all code is indented by 2 spaces when you're going to make an indent. C. It is permissible to declare multiple variables of similar purposes on the same line inside of the local declaration section of a function. That is not permissible by this class. Every variable has to be on its own line, so it's also false, and D is false. Question 4. Which of the following statements regarding the design of a program to solve a problem is false? A. Except for the most simple program, one set of test data will not completely validate a program. That is true. Once your program gets even a little bit complicated, you're going to need to have multiple sets of test data to completely validate a program, so this is false. B. Or that is true, and it's not our answer. B. Software engineering is the use of sound engineering methods and principles to obtain software that is reliable. That's true. That's the definition of software engineering, so it's not our answer. C, the development of software should be more concerned about correct results rather than efficient design. That is false. The development of software is both about correct results and efficient designs, because even if you have the right results but they take 10 years to get them, well, that's not very effective, is it? So C is the answer for question 4. All right, moving on to questions 5 through 6. We have another set of code with some very similar looking variables and some operator precedence expressions, but for questions 5 and 6, they're going to be looking at these strings and how they are formatted using with specification. So question 5, which of the following is the output generated by the first two print statements in the program above? The first two print statements has this formatting that is above the second print statement, and then we are printing out the volume with dot star LF or double /n, and then the width of that width specification is going to be length -1, and then it's passing the volume as well. So length is 3, so length -1 is going to be 2, and volume is going to be 70.2. Thankfully, they don't make us calculate that because they only have one answer choice. And when you have the star, that's a length of 2, so we know it's going to go out to 2 decimals because it's behind the period, which gives us answer choice B. Moving on to question 6. Which of the following is the output generated by the final two print statements in the program above? So we have to do the same thing, but for the last two statements. Now we have the width specification, the asterisk, in front of the period. So that width is going to have to be in front of the period, whatever it's defined to. And we're passing area this time, and length is going to be times 3. So again, it's 3. It didn't get modified by this first printf. It's going to still be 3. 3 times 3 is 9. And the area, well, again, they don't give us any different choices, so we can just assume it's going to be 173.7. Now, we have to have 9 spaces before the period. So if we look at answer choice C, and we count out how many spaces there are, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can see that it does have 9 spaces, including the period, which is what we want in this problem. I think I misspoke. I said before the period, that when the width specification is before the period, it's including the period. When it's after the period, it doesn't include the period. So this is 9, including the period, and our answer for question 6 is C. 7. Which of the following statements regarding the formatting of output with the printf function is true? A. The size modifier is used to specify the minimum number of positions to reserve for the output of a value. That's false. The size modifier is used to describe the size of the inputted number, of the number you're going to pass, whether it's just a float or a long float / double. So it's not going to reserve any number of positions. B. A precision modifier may be used for the output of any numeric value. That's false. A precision modifier is going to have different behavior determined by what type of output you're printing, whether it's a string, whether it's an int, whether it's a float. C. Conversion codes are needed only for the printing of data that is stored in the memory of a variable. That is false. You need to have a conversion code anytime you pass data to printf. So since none of them are true, the answer is D, none of the above. 8. Which of the following statements regarding prefix and postfix expressions is false? A. The result of an expression is undefined when multiple different variables are modified with a prefix operator a single time. That is false. An expression can still be defined if multiple different variables all have their own prefix operator. So the answer is A. Going through the rest of the questions. B. The operand in a postfix or prefix expression must be a variable. That is true. Can't be like a number or anything like that. C. The value of the postfix increment expression is determined before the variable is increased. That's true. With a postfix, it's determined before the variable increased. With a prefix, it's determined after the variable is increased. And D is not the answer. All right. Moving on to question number 9, which asks us, which of the following is the first line of output generated by the program above? So we have two printf statements, and it wants us to figure out what this volume variable is going to be after it has two expressions. And we have triangle defined as 0.5. So we have 0.5 divided by 2. Since that's dividing by an integer, this is going to turn to 0. And then that's going to get multiplied by length, which is 3. But 0 times 3 is still going to be equal to 0. And then the second expression here, we're multiplying volume. We're setting volume to volume times whatever this expression evaluates to right there. But since that expression, it doesn't matter, since you're multiplying 0 by that expression, the result is going to be 0. And the answer to question 9 is A, 0. Question 10. It asks us which of the following is the second line of output generated by the program above. So what's the output of the second line when it's printing in the area? And so to calculate that, we have to calculate 0.5 times this square root of 3 times 3 to the 4th. 3 to the 4th is 81, times 3 is 243. So this becomes 0.5 times the square root of 243, which is going to be equal to 7.7 something. But we're casting to an int, so we're going to chop this off, and it's just going to be equal to 7. All right, moving on to the second line, we're going to add to that 7 3 times 3 to the power of 2, which is 9, times 3 is 27, so this is going to be equal to 7 plus 27, which is equal to 34, and that gives us our answer, B. All right, moving on to question 11. Which of the following data type conversions does not appear in the code segment above? So the first one, implicit. Do we have any implicit data type conversions? And the answer is yes. In the first line, we're changing triangle, which is a float, to an int by dividing it by an integer. So that's an implicit data conversion. Explicit data type conversions. In this line, the first line with area, we're assigning the result of this expression to an int, which is an explicit conversion. And then assignment, when we define length, we're assigning length to be a double. So that's an assignment. So all three of those data type conversions appear in the code, and the answer will be D, none of the above. 12. Which of the following statements regarding the result of the modulus operator is 2? A. The possible result of the following for any non-negative integer, x is 0 or 1. Now this is a bit of a trick question because any number that you plug into here, 1, 2, 3, 4, 5, it's going to be, for example, 2, it would be 3 modulus 2 is going to equal to 1. However, if you plug in 0, 1 modulus 0 is actually undefined behavior. So this is going to return not 0, 1, it's going to be undefined. And so this is not true. And then for B, the result of the following for any non-negative integer x is 1. Very similar case here where you plug in any integer besides 0 and you're going to get 1. But if you plug in 0, you get 2 modulus 1, which is going to be 0. So the answer to this is if you set x to 0, the resulting expression will also be equal to 0, so it is false. And then C asks if 1 minus the previous expression could ever be 0, or is the answer to the previous expression always 0? And in this case, we just saw that the previous expression can sometimes be 0, which would leave this as 1. So this is also false. And the answer is D, none of the above. All right, moving on to question 13. Which of the following is the first line of output generated by the code segment above? In this case, we have some more modulus that we will be reviewing. And the first printf statement is printing out x, y, just x and y. So let's go through here. We're going to be setting to x modulus y. So 19 modulus 8 is going to, well, 8 goes into 19 twice with 16, so the modulus is going to be equal to 3. And then y is going to be y modulus c. So that will be 8 modulus 5. Which is going to be 3. And so both x and y will be equal to 3, which is answer B. Question 14 asks, what is the output of the second line, or the second printf statement? And we can see here it's printing z. So we see here z is set to z modulus x, but x was previously set to 3. So this is going to be 5 modulus 3, which is going to be 2. So the answer to 14 is going to be C. Moving on to question 15. Which of the following is the first line of output generated by the code segment above? And so we're looking at the output of this first printf statement, which is outputting y. So we have to calculate y, which is going to be set to the modulus of y modulus x plus 1. X is 3. So x plus 1 will be 4, and y is 18. So 18 is going to be set to 18 modulus 4, which will be equal to 2. So y will be 2, which is answer choice A. Question 16. Which of the following is the second line of output generated by the code segment above? And here we have the second output where it's going to be outputting a prefixed x plus a postfixed z divided by 3. So we go through and we do the proper operator precedence, and we're going to have to set x to, x is going to be 3 plus 1 is 4. And then z, we're not going to evaluate because it's a postfix. So it will be 12 divided by 3. And we have to divide first. So this will be 4, and then we can add it to the other 4 to get 8. So the answer to question 16 is C, 8. 17. Which of the following is the third line of output generated by the code segment above? And in the third printf statement, it's asking us what is z plus x. Now we know that z was incremented to 4 and z was decremented to 11, so it's going to be 11 now. So we have 11 plus 11 divided by a prefixed x, which is going to be 3, since 4 minus 1 is 3. And 11 divided by 3 is 3. And it's an integer, so we don't have to worry about the decimals. And then 11 plus 3 is 14. And then finally, we have to add z plus x, and x is 3, so 14 plus 3 is going to be 17. And so the answer is B. 18. Which of the following statements regarding user-defined functions is false? A variable declared in the local declaration section of a function can have the same identifier as one of the parameters of the same function. That is false. You cannot have a local variable that is the same as one of the parameters of the function. So our answer is going to be A. Now going through the other questions, the other options to explain why they're true. B, a local variable cannot be referenced through its identifier outside of the function in which it is defined. That's true. It's local. It cannot be accessed from outside of the function. So this is true. C, parameters are defined as local variables in the first line of the function definition and should not be redefined within the local declaration section of the function. That's also true. When you define a local variable in the function call, it is set up for use within the function, and so you do not redefine it. So that is also true. And D is not an option, so the answer again is A. Moving on to question 19. Which of the following is the first line of output generated by the program above? So it's asking us what is the result of this printf statement, which is calling new digits and passing 45 to new digits. So we're calling new digits with 45. And then in this function, it defines int a and b, and it sets a to x modulus 10, which is 45 modulus 10, which is going to be equal to 5. And then it sets b to x divided by 10. 45 divided by 10 is going to be 4. Remember, it's integer division, so you chop off all the digits. And then it's going to set x to 5 times 10, which is 50, plus 4, which is going to be 54. And then it's returning that to be printed. So the answer to 19 is going to be B, 54. All right, moving on to question number 20. We have the same exact procedure. We just plugging in 213 instead of 45. So 213 modulus 10 is 3. And then 213 divided by 10 is 21. Remember, integer division. And so 3 times 10 plus 21 is going to be 51, or answer B. All right. Scrolling down. 21. Which of the following is the third line of output generated by the program above? So in this case, we are going to be plugging in 7. And this is a bit easier because it is not, in fact, greater than 10. So if you plug in 7, 7 modulus 10 is going to be 7. There we go, x is 7. 7 divided by 10 is going to be 0. So 7 times 10 is 70, plus 0 is equal to 70. And that is answer choice C. Moving on, 22. Which of the following statements regarding user-defined functions is false? A, not all functions that utilize pass by address are void functions. That's true. You can have a function return a value and utilize pass by address. So that's not our answer. B, when working with a parameter that has been passed by address, it is unnecessary to use the address operator in the scanf because a pointer variable already represents a memory location. that is true. You have a memory address, so you don't have to use the address operator because it's already in an address form. C. A function that passes at least one parameter by address must pass them all by address. That is false. You can have a mix of passing parameters by address and passing parameters by their actual variable. So the answer to 22 is going to be C. Moving on to question 23. Which of the following is the first line of output generated by the program above? So we're looking for the result of this first printf statement, which is calling make changes. We have set x to 5 and 3, so we're going to be passing 5 and 3. It's kind of a bad 5, but whatever. So passing 5 and 3 to make changes, we have 5 modulus 3 times 3 modulus 5. Now, in this case, now modulus has the same precedence as multiplication, so you just evaluate this from left to right. So 5 modulus 3 is 2 times 3 is 6. Modulus 5 is 1. 1 is not an answer choice, so the answer to 23 is D, none of the above. Now to question 24, which of the following is the second line of output? So in this case, we are going to be running make changes again, but we are postfixing x. So after this expression, x is going to be equal to 6, but for now it's being passed as 5. And y is getting prefixed, so it's being incremented and passed as 4. So we redo this with 5 and 4 instead. And again, we just go through this again. So 5 modulus 4 is 1 times 4 is 4. Modulus 5 is 4. So the answer to 24 is going to be B, 4. Now 25 is going to be very similar, just asking us what is the output of the third line, in which case we're going to be setting x to the result or the return of inputting x and make changes 7, 4. So this is a bit of recursion. So we'll actually have to run make changes twice. First with 7 and 4. And so this is 7, this is 4, this is 4, this is 7, 4, 4. There we go. All right, so 7 modulus 4 is 3, multiplied by 4 is 12, modulus 7 is going to be 5, so this is going to return 5. So then in this outside call, we're going to have x, which is 5, and we're going to have this result, which we just figured out, as 5, so it's going to be passing 5 and 5. So if we write that down, we're going to be putting in 5 and 5. 5 modulus 5 is 0 times 5 is 0. Modulus 5 is equal to 5, so this is going to return 5. It's going to set x to 5, and then it's going to be printing 5 on the next line, so the answer to 25 is A, 5. All right, moving on to question 26. Which of the following statements regarding course standards and user-defined function design is true? A. With the use of pass by address, it is now permissible for a function to be written to complete several subtasks of the program. That's false. A function can not complete more than one subtask of the program in this course. B. It is a good design to practice to create a user-defined function such that it is testable apart from the rest of the program. That is true. You should have a function that can be tested, not within the rest of the function or the rest of the program. Or C. A function that accomplishes multiple processes is functionally cohesive. Functionally cohesive means that each function has its own role and only completes a single process in the program. So having a function that accomplishes multiple processes is not functionally cohesive, so that's false. And the answer to 26 is B. All right, moving on, we have some work with srand and rand in this function. So 27, which of the following is the correct use for the srand function call? And this is basically just, you have to know it. You pass the seed and srand doesn't return anything. So the answer is B. Moving on to 28, it asks, which of the following is the smallest possible value assigned to the length 2 variable in the code segment above? And length 2, we can see it's passing 210 to create random, so we'll see what that does. Pass 200 and pass 10. And so then it creates this other variable called length, or len, and it's going to set length first to a random number modulus by a. Well, that random number can be anything, right? So we have to use the properties of modulus to determine the max and the min. And if you modulus a number by 200, well, the lowest it can be is 0, because if rand is 200, then the answer is 0. So the smallest possible value is 0. And then we're adding to len, rand modulus b. Again, rand can be anything, so if it's 10, modulus 10, that will also be 0, so you're going to add 0 to 0, and the minimum value will actually be 0, which 28, the answer is A. All right, moving on to 29. Which of the following is the largest possible value assigned to the length 3 variable? So here we're running create random again, but we're going to pass 150 and 5. And it's asking us what's the largest possible value that create random can return. Well, again, random can be anything, but if it's modulus by 150, then the largest number possible that will be not divisible by 150 is 149. And similarly, if we have 5 as the second one, the largest possible number that is not divisible by 5 will be 4. And it says, which of the following is the largest possible value? And the correct answer should be 153, which is 149 plus 4. That's not an option, so the answer choice is D, none of the above. All right, moving on to question 30. Which of the following is the first line of output generated by the program above? The first line of output here is printing A and C, and we can see that it's plugging in AB and BC as addresses to find value, which is pass by address. So we have to run this code here, where again we're going to pass A and B. So we're passing 11, or really we're going to pass the address of 11 and the address of B, but those values are 11 and 8. And here we're going to set AX to 11 minus 8. We're using the dereference on these pointers, so this is going to return the value and not the address. 11 minus 8 is 4. No, not 4. 3. All right, and then we're setting a y to the sum of, now this is going to be 3 plus 8, which is 11. Here, we'll set this to 3. And then we're going to be setting AX again to AY, which is 11, minus 3. So that's going to be 8. So in this case, it is swapping the values of the two numbers. So then here, we're now A has been turned to 8, and B has been turned to 11. Now we have to run it again, and we're going to be putting in B, which is 11 now, since it got changed after we ran it the first time, and C, which is 12, because it's still the same. And this is going to be 11 minus 12, set it to 1. And so then 1 plus 11, plus 12 is going to be, 11 minus 12 is going to be negative 1, and then negative 1 plus 12 is going to be 11, and then we have 11 minus negative 1 is going to be 12, so again the values were swapped, so this is going to change to 12, and C is going to change to 11 for that second iteration. So then 30, we can go back, we can see what the first output is. It's printing A and C, which is going to be 8 and 11. So 30, the correct answer is A. And then 31, which of the following is the second line of output? It's going to be printing B, and we can see that B is going to be equal to 12. So 31, the correct answer is C. 32. Which of the following statements regarding structure charts is false? A. Each rectangle on a structure chart represents the user-defined functions used in a program. That's true. Rectangles represent functions in structure charts. B. A structure chart demonstrates the order in which user-defined functions are called in a program. That's true. You use it to figure out the order of your functions. C. The passing of data to user-defined functions in a program can be indicated on a structure chart. That's also true. You can write down what data you're going to be passing. So the correct answer to 32 is D, none of the above. All right. Moving on. It asks to use the program for the problems 33 to 34. And the first question, 33. Which of the following is the first line of output generated by the program above? You can see that it's calling another function, and it's passing 5, 3, and 4, and then it's printing the result of that. So we just have to plug in 5, 4, and 3 to this calval function. So it says F1 is going to be 5 divided by 4 plus 5 divided by 3. Now this is both integer division, so that's just going to be 1 plus 1, which is going to be equal to 2. And then it's setting F1 to 1 divided by 2, which is 0, because again it's integer division, times x, which is 5, but it's 0 times 5 is equal to 0. F2 is going to be 4 divided by 0, which is going to evaluate to 0, plus 4 divided by 3, which is going to evaluate to 1, so that's going to be equal to 1. And then 1 modulus 2 is 1 times y, which is 4, is equal to 4. So here we have the expression 1 minus f2 plus f1. f2 is 4 plus f1 is 0 plus 2, so this is going to be 6 modulus f2, which is 4, plus 0 plus 1, which is 5, which is going to be 1, and then it's going to be 1 minus 1 is equal to 0. Then multiply that by z, you're going to have 0. So f3 is 0, f1 is 0, f2 is 4, 0 plus 4 plus 0 is equal to 4. All right, moving on to question 34. We have to do the same thing, but with the second inputs. This time we're inputting 3, 3, 4 into the question. So jumping right into F1, we have 3 divided by 3 plus, which is going to be 1, but plus 3 divided by 4, which is 0, so that's going to be 1 because 1 plus 0 is 1. And then we have 1 divided by 1, which is 1, times 3 is going to be equal to 3. F2, 3 divided by 3 is 1, plus, in this case it is 3 divided by 4 is 0, so that's going to also be 1. And then we have 1 modulus 2, which is 1, times y, which is 3, is going to be equal to 3. And then for the last one, we're going to have 3 plus 3 plus 2, which is 8. Modulus 3 plus 3 plus 1, which is 7, so that's going to be 1. So that's going to be 0 times 4 is still 0. So 3 plus 3 plus 0 is 6. 34, the correct answer is A. 35. Which of the following is a requirement to receive any credit for this exam? A, your name and student identification number in both written and bubbled in on the exam answer form. B, you are seated in your assigned seat. C, the cover of the exam lists your CS159 instructor. D, all of the above. Nice freebie they give you there. Alright, so that concludes this review of the CS159 first midterm. I hope you found it helpful. And if you find any issues or problems with my explanations, please leave a comment and I will fix them. Goodbye and good luck on your exam.